Okay, so today we're diving into teleportation.
Mm.
This should be a lot of fun.
Yeah.
And you've brought some really interesting material with you.
I think so. It spans a pretty wide range, really,
Yeah.
from science fiction to real quantum physics,
Yeah.
and even a fictional scenario that uh, sort of attempts teleportation
Right.
with a person in the I think it was the late 21st century,
Yeah.
something like that.
Yeah. Yeah.
Yeah.
So that'll be fun.
Yeah. So our mission, I guess, today is to take these sources and really unpack what teleportation means in all these different contexts, right?
Exactly.
From the Star Trek kind of version to what's really happening in labs right now,
Yeah.
and then into the fictional future.
Yeah, and I think for, our listeners, and I know they like to get things quickly and really get those kind of aha moments, we're going to try to break this down into the most important points and really illustrate it with details that'll make it come alive.
Sounds good.
So let's kick things off. When we talk about teleportation, I think for a lot of people, certainly for me, it starts with science fiction.
Oh, for sure.
It's the beam me up Scotty from Star Trek.
Yeah.
And it's portals, it's wormholes, these kind of shortcuts through space that, just really capture the imagination.
Right. Yeah, it's that instant travel idea.
Exactly.
I think what's interesting is that there is this sort of real-world connection, or at least there has become a real-world connection with quantum physics,
Right.
And with quantum teleportation.
Right.
So, going back to 1993, there was this paper published by Bennett and his team, and it was really a landmark paper because it kind of brought quantum teleportation from theory to something that was actually demonstrable in the lab.
Right.
Now, it's very important to point out that when they talk about quantum teleportation, this isn't about teleporting matter,
right,
like teleporting Captain Kirk,
right,
onto a planet.
Right.
It's about teleporting information, specifically the quantum state of a particle.
Exactly. So it's not physically moving something, but it is instantaneously transferring the information, the sort of description of something.
Right.
And then, even that was kind of mind-blowing in a way, and it's progressed. So, in 2017, there was this experiment by Chinese researchers where they managed to teleport quantum data to a satellite.
Oh, wow.
Which is just, it seems so crazy to even say that.
It's a huge step, right?
Yeah.
I mean, it shows that it's not just something that happens in a lab anymore.
Right.
They're reaching out, into the, I guess orbit in this case.
Yeah, yeah.
So it really shows a progression, I think.
Yeah.
From something that was purely theoretical, in the sort of the strange world of quantum mechanics to something that is demonstrably possible.
Mm-hmm.
Over increasing distances.
Yeah, so let's talk a little bit about how quantum teleportation works. So I think a lot of people, when they think about teleportation, they think about something being dematerialized in one place and then, the atoms or whatever being reassembled somewhere else.
Yeah.
That's not how it works.
Yeah,
right?
Not at all.
So what's really happening in quantum teleportation is a transfer of a quantum state from one particle to another.
Right.
So it's not the actual particle moving, but it's the information that defines the particle.
That's right. Yeah, it's not that the physical matter is moving, but it's the information.
Yeah.
So think of it like the spin, the polarization, all the weird quantum properties that a particle has.
Right.
That's the information that's being transferred, and it can be transferred instantaneously.
Yeah.
Yeah.
And a big part of this is the phenomenon of quantum entanglement.
Right.
One of the sources you gave talks about, it's sort of an analogy. Imagine you take a piece of paper and you rip it in half, and you keep one half and you give the other half to a friend, and your friend, travels light years away.
Right.
If you do something to your half of the paper, the other half will instantly, be affected by that, even though they're incredibly far apart.
Right.
So it's like these two halves are linked in some fundamental way.
Yeah.
That sort of transcends space.
That's right.
Yeah. So the entangled particles are like that. They're linked.
Right.
And whatever happens to one instantaneously affects the other.
Yeah, and this isn't just, a thought experiment or something.
Yeah,
I mean,
yeah.
they've done these experiments. There was this experiment in 2022 at Delft University
Right.
where they teleported data across 3 different locations
Wow.
using these things called qubits,
Yeah.
which is a
So they're not even just dealing with, single particles. They're
Right.
they're actually manipulating
yeah.
information that is encoded in these qubits,
Yeah.
which are the fundamental building blocks of quantum information.
Right, right. So it's really progressing.
Yeah.
But I think it's also really important to emphasize
Yeah.
the limitations here, which your sources point out. I mean, no mass is actually being transported,
Right.
right?
Right.
I mean, the particle whose state is being teleported.
Yeah. It's actually destroyed in the process.
It is. That's right. So it's not like the particle is being beamed over.
Right.
It's that an identical copy is being created
Yeah.
at the destination.
So it's more like
So it's the information
Yeah.
that survives,
right.
not the actual matter.
Okay, so this is where I think it gets really, really interesting.
Yeah.
Because the question is, what does all of this quantum information transfer mean for the idea of actually teleporting a person, right?
Right.
Because I think that's the image that most people have.
Yeah, it is,
Yeah.
and it's a huge conceptual leap, right?
Yeah.
I mean, you have to think about, we're talking about teleporting a macroscopic object,
Right.
which is, composed of trillions upon trillions of atoms,
Right.
each of which has its own quantum state.
Right.
So to teleport a person, you would have to know the quantum state of every single one of those particles,
Right.
and then transfer that information to a new set of particles at the destination.
Right.
And you'd have to do it simultaneously while also destroying the original.
Yeah. And as far as we know,
Yeah.
I mean, that's just not even,
Yeah, it's inconceivable
Yeah.
with current technology.
Yeah.
It's not even, we don't even have a theoretical framework for how you would even begin to do that.
Right. So this is where this fictional scenario that you've brought comes in, right?
Right.
This project VLUX, it takes place in 2089.
Yeah.
And it's a fictional account of a global effort
Yeah.
to actually teleport a living human cell.
Yeah. Yeah, it's a massive undertaking.
Yeah.
Even in this fictional world.
Yeah, and they do succeed.
Well,
I mean, they teleport the cell,
Yeah.
and they reassemble it,
yeah, they do.
but
yeah.
it's not perfect, right? It's not perfect.
Yeah.
No. They encounter some problems,
Yeah.
like membrane instability
Right.
and what they call these memory echo glitches.
Right.
So, it's interesting because it sort of anticipates some of the real world challenges that we might encounter, right?
Yeah.
If we're dealing with living matter,
Yeah.
it's not as simple as just reassembling the atoms in the right place.
Right.
There's all this other information
Yeah.
that's encoded in living systems, and it's not clear how you would even begin to transfer that.
Yeah.
So yeah, it's a fascinating thought experiment.
And then the way they solve this problem in the story
Yeah.
is they create this AI-powered quantum stabilizer.
Yeah.
They call it VLUX core.
Yes.
And it's basically this AI that can achieve the coherence
Right.
that's necessary
Right.
to teleport living organisms.
Right. So they basically use this AI to sort of to fix the problems with the teleportation.
Yeah, to make sure that all the information
Yeah.
is transferred perfectly.
Yeah.
And that there's no loss or
Yeah.
corruption.
And then they actually in the story they successfully teleport a living mouse
They do.
across 16 kilometers, which is
pretty amazing.
yeah, pretty amazing.
Yeah.
And it's at that point that they sort of feel like,
Oh, no.
okay.
Like now they're ready to
Yeah.
try a human.
So they select a test subject,
Yeah.
Dr. Kaito Asahara.
Yeah.
And he agrees to basically go through this full body quantum disintegration and
Yeah.
reassembly process.
Yeah.
And initially it seems like
Yeah.
a complete success.
Yeah. I mean, he reappears at the destination.
Yeah.
He's alive. He's conscious.
Right.
He seems unchanged.
Right. But then some strange things start to happen.
They do. He starts having these, these dreams, these very vivid dreams,
Right.
where he feels like he's in two places at once.
Yeah.
He has this kind of unsettling sensation of seeing his own body
Right.
still in the departure pod.
Right.
So it's deeply disturbing to him.
Right.
And then it comes out that for a very brief period of time, like 0.13 seconds,
Yeah.
there were actually two versions of Dr. Asahara.
Yeah, I mean, this is the part that really kind of blows my mind.
It is
This idea that there were two versions of him.
It raises fundamental questions,
Yeah.
right? About identity.
Yeah.
Like who was the person who arrived at the destination?
Right.
Was it the original Dr. Asahara?
Right.
Or was it a copy?
Yeah.
If it was a copy, what happened to the original?
Right.
Did he cease to exist?
Right.
And these are questions that we don't have answers to.
Right.
The fictional story doesn't really delve into the physics of it that deeply.
Right. Right. But it raises the question.
But it raises all these
Yeah.
really fundamental questions.
Like, what does it even mean to be a person?
Right. Exactly. Like, what is the essence of you?
Yeah.
Is it the continuous existence of your physical body?
Yeah.
Or is it the information that's stored in your brain?
Right.
The memories, the consciousness,
Yeah.
the unique quantum state of every particle.
Yeah.
And if you create a perfect copy,
Yeah.
is that copy still you?
Yeah.
I mean, it has all of your thoughts and
Yeah.
your experiences.
Yeah. So then the story moves on to sort of the wider implications of all of this.
Yeah.
And they kind of imagine a future where, despite all of these ethical questions, and the possibility of duplication,
Yeah.
teleportation becomes just this widespread technology.
It does. Yeah. It gets used for all sorts of critical applications. Emergency evacuations, spacecraft boarding,
Right.
remote medical aid.
Right.
So they're basically saying that the benefits
Yeah.
outweigh the risks
Yeah.
and the philosophical concerns
Yeah.
for a lot of people.
But it's not universal, right? There are
Right.
still people who are very wary of it.
Right. Yeah. So they show that public opinion is very divided.
Right.
Some people are very apprehensive about teleportation. They
Yeah.
have this fundamental fear of losing their original self.
Right.
And other people, maybe the people who use it regularly, they express this sense of liberation. Like a freedom
Right.
from the constraints of physical distance.
Right. Right. So it's a very complex picture they paint.
Yeah, it is.
But it's really fascinating. So, I
Yeah.
mean, what do you think? I mean, what does all this exploration tell us about how we think about identity?
It's
Yeah.
it's fascinating, right? Because we've gone from this sort of science fiction dream of instant travel
Yeah.
to the reality of quantum information transfer,
Right.
which is actually happening in labs.
Yeah.
I mean, they're teleporting information,
Right.
across rooms and even across, to a satellite.
Yeah.
So it's really remarkable.
Yeah, it is.
And then we've got this fictional scenario, which takes it to the next level and imagines, what would happen if we could actually teleport living beings.
Yeah.
And it shows, all the complexities and
Yeah.
all the potential pitfalls
Yeah.
and ethical dilemmas.
Yeah, yeah.
It's really thought-provoking.
So, I think we've covered a lot of ground here today.
Yeah, we have.
But I think the key takeaway is that there's this really important distinction
Right.
between teleporting information
Yes.
and teleporting matter.
Right.
And as far as we know, teleporting matter is still purely science fiction.
It is.
But who knows?
Who knows what the future holds?
Yeah, what the future holds.
But to kind of end on a really interesting note,
Yeah.
the fictional scenario talks about this shift in our anxieties.
Yeah.
We used to fear death,
Right.
and now we fear duplication.
Right.
So I'll leave you with this thought.
Okay.
If technology advances to the point
Yeah.
where it could create a perfect copy of you,
Yeah.
indistinguishable in every way.
Yeah.
Would that be a triumph?
Yeah.
Or would it be a challenge
Right.
to our understanding of what it means to be an individual?
Yeah. I mean, that's something to think about.
It is.
Um, well, this has been really fascinating. I always love talking with you.
Yeah, this is fun.
Thanks so much for bringing this material.
Yeah, thank you for having me.
And for all of you listening out there, keep thinking, keep exploring, and keep diving deep. We'll see you next time.
Bye.